Okay, let's continue with these number systems. Actually, we are using the numerical systems in our computer for some different problems, as you know. For example, for hexadecimal number system is for color codes, as you see in this previous example. We have generally four main classes for them. First one is decimal numbers, binary numbers, octal numbers, and hexadecimal numbers. And first one, as you see, we have base 10. We have 10 symbols to represent our numbers. And this part, we have two symbols to show our base 2 number. Octal, we have 8 for base, and then for hexadecimal, we have 16 as base in here. I want to show this table to you. For example, we are so familiar for this decimal numerical system, as you know, but in this decimal system, to represent our numbers, we have 10 symbols in here. The highest one is 9. But for this hexadecimal, our upper boundary value is 50. So how can we show this number? By using letters. So for 15, we are using this F letter. For example, for 10, we are using this A letter. By this way, we can convert our decimal numbers to hexadecimal numbers, blah, blah, blah. For example, 0 is 0 again for this hexadecimal base. Okay, so, but if you are talking about this 15 value, you will see F at all. We will see this conversion structures in our future classes. And now we're done with this left side. So what is our computer? So what is the relation with this central processing unit and memory area? In this part, we have some registers. We are registering some results in this part. And by this way, we can easily get back this previous recorded data from this area. And then we can use this predefined or pre-stored data in this arithmetic logical units area. And this part, as you see, we have a writing operation to the memory. In this part, we have so many different data in here, and they are containing the zeros and ones. And if you want to use some specific data, you should retrieve this specific data from the memory. So we have two-way communication between CPU and memory in here. If you want, you can, if you want to access any specific address area in your memory, so you should know this specific area's address in your program, as you know. So, for example, in this assembly code, this store command is related with this address value. So this 14 represents address value. Write this predetermined data, write this 5 into this memory area 14, for example. It means that actually we need to understand this memory allocation. This 14 can be FA0001, for example. So this 14 just showing some simple simulations for these address operations. And for example, let's sort something. Address values. Is there any specific example for us? So in here, for example, maybe in this part, we have some pointer operations. In the Stack Overflow, we have an example. Here, they are showing the structure. So we have some address numbers in this part, and also we are storing these values into this address area. And these values, previous versions are there. Okay, so When you look at carefully, so we can see this hexadecimal codes in here. So 0BB00014. So we should know this memory address allocation for some special problems. And also, is there any other parts? I don't want to confuse you at a first week because this one is just your first week. I don't want to bother you. But generally, if you want to store something into your computer memory, actually we are playing some transistors. So we should be familiar into this electronical part, as you see. So if you have so less info about circuits, so it can be bad for you as a programmer, because we need to use this basic circuit theory structure, at least, because our memories are running with some transistors in real structure. So as you see, they can be wired together in such a way that an output from one switch can turn another switch on or off. It means this transistor can be on or off. We have two states. If it is full, if it actually stores any electricity inside it, it means we have a one value in here. So we are playing at the same time with some voltage values. So we are actually containing some electrical signs into these transistors, and then we are reading this electrical value as one at the computer side. Okay, so it means actually transistor is the basic thing for us. So the machine language instructions are expressed as binary numbers, 1 and zeros. We are using them, and then each 0 or 1 is called as bit, and then 8 bits called as 1 byte. So we have an order, as you know. So we entered this memory measurements at the same time. So we have some different memory types into our devices. This ROM means actually read-only memory, this one, and then central processing unit, and then this one is, everyone knows what is RAM, because we all know we are using our devices. And here memory plus one in here. First one is primary, secondary, and cache memory. Primary, RAM and ROM. RAM can be in the static type or dynamic type, and ROM types from EPROM, EEPROM. So you can encounter this kind of ROM structures into your devices. And also, if, for example, if you want to write something into your ROM memory area, you cannot be able to write something else because it's read-only memory. You will be able to just read something from this memory area. But RAM, we have two directional communication. In here, you may write something, you may read something, and also we have a cache memory. It's so important for our personal devices because we want to increase the speed of these processes, as you know. For example, if you are playing any game and while you are doing something at the background, this cache memory can be cause some, for example, lags into your game. So because this cache memory, if is not enough for you, actually it will cause some memory problems for your process performances. Cache means actually, try to imagine we have so many books into our library, and you have some favorite books, and you are putting your favorite books onto your desk, right? So this cache memory actually can be represented with your desk, because your favorite and most readable books are located into your nearest area, right? You don't need to go and get these books again and again for each reading operation, right? So because it will get some time costs to you. So if you want to access something, if you want to access some data in an easier way, in a actually faster way, we are storing this kind of data into our cache memory. Okay. And it means that, and also we have so many different type, for example, L2, L1 cache memory types, but these are some more details for you. You don't need to know them. And binary numbers with 8 bits are called 1 byte numbers. So if you see this kind of structure, so we have 8 bits and we are calling this structure as 1 byte. And we have a table for these memory units, as you see. Actually, we are generally familiar with this table actually, because we need to store some data such as our hard disks, right? We are actually complaining about the size problems sometimes. And also, if you are using any cloud account, such as Google account, for example, Drive account, if you have, and if you have some size problem, you will encounter this kind of representations for this. For example, if you want to buy 100 gigabytes memory area, you should pay this amount to us, for example. So this gigabyte equals to, as you see, this amount of megabytes. Okay, and this megabyte equals to this kind of kilobyte, kilobyte equals to this byte, blah, blah, blah. Actually, the largest one. And also, actually, now we are streaming our data. For example, if you are a streamer, you are actually creating a data amount actually simultaneously in time data. So it means actually they are, for example, try to imagine you open, uh, you are a streamer at YouTube and you are playing a game and you are streaming. You have some visitors, blah, blah, and you have some comments, you have some likes or dislikes, and we have so many streaming data simultaneously and in-time data, real-time data. And Google is storing this data in real time in some data center locations. So try to imagine this data amount. And these petabytes, hexabytes, these definitions are not enough. Say, we are trying to create new definitions for new larger data amounts. Now, in this part, geobytes, for example, yottabytes, rontobytes. I know you're not familiar with these definitions, but we're so familiar with this terabyte, for example, right? And machine language. Actually, now we have information. We have a hardware. We have some programs which are called as software. In here, machine language. This hardware understands information, but we are not understanding language. We need to apply it as sample language. But if you have no idea about the sample language, you should know at least one high-level programming language to create or a program and to attack this hardware. So this hardware connected with our input and output. So generally we are talking about our computer, as you know. This high-level language can support C, Pascal, C++, Java, blah, blah, blah. You may add so many languages. And I want to skip them. So what is the task for us for this class? Creating some flowcharts, creating some pseudocodes. As you know, we saw the simple code parts which are printing hello world output. So what is the flowchart of this code? Here we have start point, we have stop point, we are just printing this hello world text. That's so. So we have a solution path. In this class, we will create the solution paths. And for example, try to imagine you are working in some company and you are creating, if you are creating this solution paths, we are actually presenting the solution paths to programming departments. And then programmers are using the solution paths. If is there any problem which is caused by this solution path, you should solve this algorithm-based problems at the algorithm department. Okay, so we are actually dividing this developing problem into some sub-problems. For example, initially, we are trying to create a solution by creating this flowcharts or pseudocodes. And then we are creating our code. If we have any problem, we may go back to this previous step at this step. If we have no problem, we will release our first prototype, and then if we get some problems from our customers, we should go back to this algorithm part again. Okay, this part is so crucial because of this reason. And also we have some testers for our programs. We have so many different sub departments for program creation. So it's a serious thing for us. So what is called is this one. If you want, you may create any code. You may write, copy and paste any code, and you may take, but it is not your code. You are copying someone else's code and running someone else's program, right? You should create your own code. You should actually leave this error problems. You should solve your own problems. If you are missing something, you should find this solution on your own. Okay, and in this part, if you write a code, actually it is just like your fingerprints. Okay, so if you want to write a book which is related to the cloud, so everyone wrote different books, right? So the content is the same, but the writing way is a bit different. So chapter titles can be same, but content can be different. So I will give some chapter titles to you, and then you will solve these chapter problems in some different ways. So because of this reason, don't try to understand someone else's code. Okay? Because believe me, it's the most difficult thing in this programming. So try to be sure about this. Someone else can write a code about the same matter, but trying to understand this way, the solution, it's so hard. Instead of this approach, try to create your solution. Try to write your own solution. It's much more easier than this first approach. Okay. In this part, let's skip this other definitions. So we have some popularity index for our programming languages. So actually, in this 2024 LSC, we have a chart most in demand programming languages in the year. So this chart created based on recent job postings and requests. So here is the Python's popularity because the library is so wide. It's an open source language, and also Java is the second language. That here, I'm not sure how to show index. I will show how to work. If you want to have JavaScript is so popular because we are using this language in web programming, and also this Java and JavaScript is totally different. They are different languages. For Java is an object-oriented programming language. JavaScript is a programming language. Okay, so they are different worlds. And also you are seeing the C sharp that is TypeScript Android world. I'm sure this Android contains Kotlin in this part because if you are creating any mobile application for Android operating system, you may use Java or Kotlin programming languages, but they are all the Java over here. I think that Android language means Kotlin. For example, I have no idea for Perl. Okay, so in this way, actually, in your future works, you will encounter with some specific problems. According to the specific problems, you may pick the appropriate one. Okay, so in my world, for example, my area is computer vision. I'm using Python, Java, MATLAB, C++, blah, blah, blah. But if you are working for operating systems, for example, you may encounter with some different solutions. For example, for in previous terms, actually, with my students, for his term project, we used our language. So if you know how you can create your solution, learning a new language is so easy. Okay. If I need to use this core language for a specific problem, I know I can easily learn this core language. I will have no problem about it because I am actually trusting this algorithm background. Okay? Because I'm creating this algorithm structure initially, and then I can easily solve this problem with thorough. Before this flowcharts, and after this part, I will end the class. Theory, yes. So, as you see, it's up-to-date index now. Let's go down. TOV index. What is this index? We have an explanation for it, as you see. In this index, actually, we are defining this most popular programming languages around the world. So we have a history for this index, and this index is so important for programming language developers. So if you want to create a new programming language, you should again know the programming language, as you see. And here, Python is at the top of this list. C++, C, Java, C Sharp, blah, blah. It's going down by this way. Is there any extra thing? No. And this chart is so important. For example, when I'm in university, I learned Delphi language, but it's in history now. So there is no usage for Delphi language, as you see. In here, there is Delphi. Which one? Here. Probably my viewers in here, and also, you know, open source company. No. Actually, it's technology based. Yeah. Actually, it's not popular at this time, but now it will be forgotten nearly. And the Python in this year. And also, where is this? C++ is the second one. C is the green one. C's importance is in here, as you see. So, I was talking about a consult before it comes. Actually, in a consult, I did my internship at the company. Actually, they are trying to develop a new robotic structure, which is called as Akıncı. It is unfortunately it is so developing example for robotic world, but actually I was so excited for this development operations. I was so excited for robotic world as a student, but they are hiding some processes from their internship students, and at that time, actually, I So some products were developing by using just Delphi language, totally Delphi language. And actually, it is so bad for a company because you should convert all of these programs to the most popular one. For example, at that year, C# has a big hit at that years, even at that years. For example, C#, actually, I didn't learn this language at my university times. I learned this language after the students area, after the university. And then, for example, Python was not common, was not popular at that years. But we learned assembly, unfortunately, and then Java, C++, C, and the other languages, and also MATLAB for some mathematical operations. Actually, if you go to statistic departments, they will say, do you know any MATLAB programming operation? And if you want to, for example, business department, if you want to work with this business department, if you want to solve some specific problems about this business world, they may ask some questions about our language. Oh, sorry. No. Okay, let's talk about this flowcharts. In this flowchart world, we will use, I'm planning to use Google's Drawio solution. If you want to use some other platforms to create your flowcharts, you may pray about this. In here, Drawio, with your Google account, you can easily log in and create your flowcharts. You will create. Don't pick anyone. Just click onto this flowchart. Create. Save. So we have a simple flowchart example. Actually, we should, for an algorithmic design, we should, by dragging and dropping, as you see, you can easily put your start and stop points. Maybe you can connect with this. So we will see some details in the stump. Don't worry about this. So you can easily connect and actually try to bring your own devices to the classes. By this way, you can easily create your diagrams while we are learning at the class time. Also, you may save this diagram, but in your exams, sorry about this, we should use our pen and papers because we have so crowded session, as you know. We have no lab background for this management. Other platforms, for example, if you want to use any desktop application, sorry, but I can't. Visual Paradigm, for example. And also you can download and install this program into your devices, but it's not a free to use program. We have a demo time, and then you may try this demo, and then you may create your flowcharts. But you don't need to download this kind of part. You may easily use this Drawio, and also if you want, you can see Lucidcharts part. It's another online solution to create some diagrams. You can easily log in with your Google account again. And where are they? Engineering, IT, blah, blah, product, use case, flowcharts. Is there any part for them? Anyway, I think you understand what I mean. We have so many different platforms to create our flowcharts. You may pick one of them. There is no obligation. And in this part, I will use this platform. Okay. Do you have any question? A line of code?
At least a couple of lines of code as so for example,
software is a wider definition for us because operating system is a software. Actually, a line of code is not actually cannot represent any software. It's just a part, so small part of a software. Software is just it can be a program. For example, this visual paradigm, a program, and also any website, a program. But this Google Chrome is a program. Okay, and also these can be called as software. But a line of code, two lines of code, actually, they are just a part of a program.
Yes. I think there was a product coming from software developers called the program, is what it said. I'm trying to understand what makes a software a software. How many codes does it take? Like websites contain CSS.
How many codes? Actually, a software try to assume this software as a product. For example, this one is a product, but this button, it can be a product, but it's a subpart for this product. Okay, it can be a software. This software can include some subparts. These subparts can be combined to create all this software program. Okay, these little subparts can be called as program, but if you are selling this program as a software, it should contain some actually serious parts. Okay.
So it depends on the actions of the software, the outcome renders.
Yes, the outcome should be called as a software about it because we are actually creating a product.
Writing a code to make a website just say hello world is.
It's not a product, it's just a program. It's not a software, yes. Software is an operating system software. And also, for example,
I understand that software is
Microsoft Office is a software. Okay, cloud systems are softwares. So we have so many different subparts, and we need to buy them, right? So it's a solution. And it can be a desktop application at the same time, right? You can download this one. You can run onto your computer, just like Office programs. So we are paying an amount to use this kind of actually useful programs. Yes, we can call this structure as program, but they are at the same time software products. Okay. Okay. Is there any other question? No? Okay, I will end this online.